So hello to everybody. Good morning, good afternoon, good evening, wherever you are. It's my pleasure to be part of the Healthy Longevity Summit. And this is really, I guess, just an opportunity to discuss topics of interest. And I was asked to present a little bit about my work, which I'll do very briefly, I think. Just kind of an overview of a little bit of a historical segue from where we started in terms of the work we do into some things we're working on now. In a broad context of aging, we're very interested in the biology of aging. We do a lot of work in stem cells in this area. So let me just, I have a PowerPoint presentation. So I'll just share this and I'll talk through this for a bit and then we'll have a discussion. Great. Emma, so does that look okay? Okay, great. All right. So, like I said, we're very interested in the biology of aging and really understanding at a very deep level, molecular level, what it means for cells and tissues and organisms and people to get old. And we've been studying this for many years, like I said, really in the context of stem cell biology, but we're interested in this very broadly in terms of, I guess I would say, cellular aging. And in particular, we're interested in this idea of rejuvenation. 15 years ago, 10 years ago, even then, we might have wondered what that word means, and we still debate what that word means, and it's used quite loosely. But I think that there's compelling evidence from a lot of different lines of inquiry that cellular aging is something that's reversible or modifiable. And what led us to that idea and how we're approaching this now in terms of ultimately therapeutics. So we had done some work in the early 2000s looking at aging of cells in mice, and we've done these experiments called parabiosis. And that kind of pioneered the use of this in studying cellular and tissue aging. By connecting these mice together, for example, young and old mice, we found that the fact that something in the blood of the young mice was actually making the tissues and cells of the old mice appear to be younger, and actually the old mice themselves appear to be younger. They looked better, they were healthier. And we were looking at this in terms of, I won't go into the details here, but just a regenerative response in muscle, in skeletal muscle. We're also looking at this in liver. And with age, when you have an injury to muscle, you form this scar tissue, which I'm showing here, where you see very little of that in the young. But when an old mouse is connected to a young mouse, or as later shown, receives blood from a young mouse, that regenerative response is much better. You see much less of that scarring. The tissue regenerates much better. Well, this approach was used in a variety of different systems and showed really across lots of cells and tissues that this pairing, so something about factors from young animals going to the old animals, can rejuvenate. So we showed muscle and liver, and then neurogenesis with our collaborator, Corey, and all these different tissues have been looked at in these kinds of contexts and showing this kind of rejuvenation. So parabiosis is obviously not something that can be applied to people. So we've been interested in ways to understand what happens during this rejuvenation response, and can we begin to develop this as a conceptual framework, ultimately, like I said, to develop therapeutics. So we started by looking at the common interventions in the aging field, diet and exercise. It's just an article from the New York Times several years ago, basically giving you this formula that if you run for an hour, it adds 7 hours to your life. So as a runner, I was very pleased to see this because it means you can just keep running and then live forever. Probably not true, but there's a lot of interest, of course, in the health benefits of exercise and vast literature on the health benefits of exercise in terms of preventing age-related diseases. So we asked whether exercise in mice in the form of running on these wheels would actually restore youthfulness to old muscle stem cells. And in the paper we published last year, we showed, so this is a measure of muscle regeneration after injury in young versus old mice without or with exercise. So exercise has very little effect on regeneration in a young animal, but in an old animal where that regeneration declines, exercise has a profound effect in enhancing tissue regeneration. And again, this has been shown in many different tissues and contexts. But what we have found, not in these details either, is that with age, there's a decline in this gene in protein cyclin D1 in muscle stem cells, and exercise restores that level of cyclin D1 back to what you see in young animals and restores the ability of old cells to now repair tissue like young cells. So a very molecular transducer of this physical activity. And one of the interesting things that we didn't play up too much in the paper, but it's interesting, is that if we take blood from an old animal and transfuse it into an old animal, or we take blood from an old animal that has been exercised and transfuse it into an old animal, the plasma blood from the exercised animal, this is a measure of stem cell activity, is actually enhanced back towards a youthful level. So that says that the exercise itself is not just affecting the muscle in terms of the local activity of the muscle, but actually it's secreting something into the blood from some tissue that's actually having this kind of rejuvenating effect. So this means that that like the parabiosis, there are these circulating factors that are modulating aging and restoring youthfulness. Okay, so what about diet? So there's a lot of interest in things like caloric restriction in terms of benefits to old animals and longevity and prevention of age-related diseases. So we've been recently studying fasting. This is unpublished data, but we're looking at muscle regeneration in mice that are fasted for up to 2.5 days and then refed at the time of the end of the fast. And we look at the regeneration of muscle when the mice are injured right at the end of the fast. So whether 1 day, 2 days, 2.5 days, this is a measure again of regeneration. You see, with fasting, regeneration is actually impaired. Okay, so that's not a good thing. That suggests that fasting actually impairs stem cell function, impairs muscle regeneration. In fact, that's what we found. However, there is a benefit. And if we look at this here, so these stem cells sit in a quiescent state, and they are ready to activate and repair muscle if needed. And they have a certain degree of resiliency sitting in this quiescent state. But in response to fasting, they have a decline in readiness to activate. So they're less able to repair tissue, but they're much more resilient. I'll show you one piece of data that suggests that. So even though during the fast, there's actually an impairment of activity of these stem cells, there's actually a benefit to these stem cells in terms of resilience across a period of time long after the fast ended. And this is just looking at a measure of cell death in young versus old animals. And this is not fasting, but in response to fasting, one of the things that happens physiologically is you have high levels of ketones in the body. So instead of fasting, or in addition to, or as a substitute for fasting, we actually directly injected ketones. The same thing happens if we fast the animals. By injecting ketones, there's a reduction in cell death in young animals and an even greater reduction in cell death in old animals. And the old animal stem cells now have basically the resilience of a young stem cell. What we found, again, we haven't published this, but these ketone bodies, beta-hydroxybutyrate, that are secreted from the liver in response to fasting, they enter the blood, factors in the blood, and they go to cells, and they actually participate in reactions that actually enhance cellular resilience. I won't go into the details, but again, that's very interesting to us. And it's interesting because this is a way that evolution has co-opted metabolite beta-hydroxybutyrate, which is used for energy, and actually used it to also promote resilience of the stem cells during the fast and after the fast. So I'll just end here. So this is again where we're headed with this, is kind of thinking about systemic factors that regulate aging, that promote rejuvenation, and that are beneficial and potentially could be turned into therapeutics. And just as a disclaimer, I'm a founder of a company called Fountain Therapeutics, which we have a platform developed specifically for screening drugs and potentially biologics that have this potential to restore youthful properties to old cells and basically enhance resilience as a way to prevent, delay, or even treat age-related diseases. So this is my group. I'm very grateful for all the work they do. This is pre-COVID, and that's it. And I'll stop there, and I'm happy to now have a discussion with the group on anything related to this or other topics of interest.
And feel free to type any questions in the chat or raise your hand and speak up, whatever you're comfortable with.
Actually, I see one note in the chat. Emma, is the audio not good for you also? Someone said the audio was choppy.
It's a little choppy going in and out.
Okay, sorry about this.
I was still able to hear everything.
Okay.
you said.
Apologies, I'm traveling right now. I'm not in my office. So Dan, you have a question? Feel free to unmute and.
Yeah, okay, it's very nice talk, but the sound is a little bit chirpy. I could probably hear half of that, but I can get the sense that what you want to talk. Okay, so my quick question is for the older people. Okay, so when they're old, it's like about for 70. Do you think for the dietary, for the diet of what restriction is the good? Because they already, I see my parents, they are 90 now. I see they really graduate right now. They cannot and they eat as much as they used to be. So, so it's into what point for the dietary supplement, for the restriction?
So, excuse me, I think that's a good question. And again, I apologize for the audio. I can't hear it. So I'll try to speak slowly and hopefully you'll hear much of what I say. I think your point is well taken that we have to be careful about recommending dietary restriction and fasting for older people. And really for the reason that I mentioned, that when we measure cellular function during the fast or during the dietary restriction, we often see that there's an impairment of function. And the benefit of fasting or caloric restriction is really in the longer term. So there are many things that occur with fasting and with dietary restriction physiologically that are not beneficial. And so I would second what you said. I would agree that we should be cautious in recommending this as an intervention for people who are already old, especially for people who might already be a bit frail and not have sufficient sort of body fat to handle substantial caloric restriction or fasting.
We also have a question in the chat.
So, okay, so good question. So this is from Vijay Kumar, who asks, does NMN mimic the effects of exercise? Good question. I think that, the NAD precursors and the NAD itself are mimicking a part of the effects of exercise. I mean, I think one of the things that is of interest is if we take exercise or diet and we ask what are the molecular mediators of the benefits of those interventions, they're going to be many. They're going to be complex. We and many other people study this. And in the exercise paradigm that we studied, we did narrow down on one physiological response, a major physiological response, which is ketosis. And that can be narrowed down further again to ketone bodies, acetoacetate and beta hydroxybutyrate. That pathway, that effect of fasting is clearly a mediator of cellular effects that are not part of the NAD pathway. However, there would also be pathways that involve other signaling pathways and the NAD pathway as a response to exercise. So I would say NMN and other things mimic parts of the beneficial effects of exercise.
So I have a question, go back to the fasting. So what do you mean the fasting? Is mean the time of the day to restrict and do they take the food, or is the total calorie is going to reduce? So what is your definition of the fasting here?
So what I was referring to fasting in my talk is no food, just water. And there are many versions of fasting. So meaning there's timed fasting. So you fast for a period of time during every day, or, for a certain number of days, or intermittently. But fasting, I think by definition means truly no food during the time, as opposed to what you ask about reduction in calories, which again is very interesting and has some of the same effects of fasting, but can be quite different. So caloric restriction, or I should say dietary restriction, takes many forms. So reducing total calories, reducing certain types of nutrients, focusing on certain amino acids. So there are different ways to restrict food and nutrients that are very specific, which I think are very different from fasting. And so just to answer your question, when I said fasting, these experiments we did in mice were truly no food, just water for those periods of time. And there are certainly people who practice fasting as for religious reasons, obviously, and then, but for health benefit reasons. In fact, I do that. I fast 1 day a week with the belief, I don't have any proof of this, but there's evidence from animals that actually will have some beneficial effects long-term in terms of health. But I would, I'm cautioned by our own data saying that during the fast itself it's not when you want to get sick or get hurt. But the belief is that by intermittent fasting periods of time, that you are having longer term benefits of health. And that I think that's what we're interested in exploring in the lab, is how do we understand, even if there are detrimental effects during the fast, how do we understand the long-term beneficial effects of that occur long after the fast has ceased?
Okay, thank you very much. I think I do not know whether how much data for the epidemiology data regarding to the fasting and the long term of the benefit.
Yeah, I mean the epidemiologic data is not as strong because it's difficult to do controlled experiments or even just collect data that really can speak to long-term benefits of intermittent fasting. So the strongest data obviously is from animal studies.
Dr. Rando, thank you for your presentation. Which biomarkers do you look at, or is your lab looking at primarily? Is it A1C? I know it's not an easy question. It's kind of like asking what's the best test to predict long-term success, and you settle on the SAT or something, or the MCAT or something. But if we're always looking for short answers, but is A1C or C-reactive protein, or perhaps what's your experience with what biomarkers, et cetera, that we can follow as some measure of longevity or relative lack of aging?
So it's a good question. So, and again, I apologize, Vijay, for the audio if it's still coming off.
It's actually better now. Thank you, Dr.
Is it better? Okay, sure.
Yes.
So we haven't really studied biomarkers, certainly not the conventional medical biomarkers like A1C, things like C-reactive protein, as markers of what I would consider long-term benefit. What we've been studying is this: we've been looking at epigenetic marks, and if you're familiar with this, the field, you'll know that people are looking at these so-called epigenetic clocks, and
right,
which is DNA, which we're not looking. We're interested in that, but we're looking at things like that, which is to say, if through these different interventions, and I'm going to lump here parabiosis, fasting, and exercise. Now they're vastly different, but on some level, we hypothesize that there's some final common pathways of rejuvenation, meaning benefits to old cells that make them more functional like young cells. And we believe the effects are perdurant. They last long after the intervention. We have data from all of these studies saying exactly that. So we believe that and we have evidence that this information, this beneficial information, is encoded in the epigenome. That is, when you take away the fast, or you take away the exercise, the cells have a memory of what they went through, and that will be recorded in the epigenome. So it should and would be recorded in, for example, DNA methylation. We look at histone modification. And we have data on this suggesting there are lasting epigenetic changes. But your question is a good one. So can you measure something from a simple blood test that would reflect these epigenetic changes? And we are doing proteomic and metabolomic studies of blood under these different conditions. So from this, we hope what will emerge are biomarkers that are reflective of kind of the total body epigenetic state and essentially the biological age, which is what the methylation clock, the epigenetic clock, promises to give us, is a biomarker of cellular age. And so a long way of saying we don't have a simple blood test like you're asking, but we're certainly looking toward that.
Excellent. Thank you, doctor. Very helpful. And actually, if there are no more other questions, you may have heard of these. I've heard of these peripherally. I haven't really researched it, but apparently the affluent are getting platelet-rich transfusions, or following on the concept of parabiosis. Presumably, if you take the plasma of a young person and infuse it into an older person, whatever is in the miasma there or whatever, do you find any basis for that scientifically, or is there any evidence for studies we can point to look at that?
So there are no studies to support the health benefits of receiving, and I know what you're talking about in terms of there are companies promoting this that support the idea that a couple of transfusions of plasma from a young person to anyone, to a young person, a middle-aged or old person, has any long-term or even short-term benefits. So, I mean, as you say, that idea emerges directly from the parabiosis studies and the plasma transfer studies.
Right.
Where, the plasma transfer studies and the parabiosis studies are, well, let's say the parabiosis studies, those animals, the old animals in those parabiotic pairs, are receiving young blood 24 hours a day, for 3 months. And the notion that a couple of transfusions of a couple of units of plasma could have a lasting benefit is orders of magnitude different in terms of the intervention. And even the plasma transfer studies that we and others have done are repeated plasma transfer every week for many weeks, and then looking at the effect at the very end of that period of transfusion. No evidence of kind of really long-term benefits, beyond that initial period. So yes, I would say that from my experience and from what I know, there's no reason to think that getting a couple of transfusions of a couple of units of young plasma will have any benefits, and there certainly are risks. So it's not something I would encourage, based on the data that we have in hand at all.
Thank you. Very helpful. Thank you, doctor.
I mean, please go ahead.
So come back with for the blood and the diffusion. So what do you think? And if you just refuse do the diffusion with your own blood, for example, when you're 20, you just save your blood and do some blood. When you're like 80, then diffuse your own. So what do you think of that?
I mean, I think you'd have to save. I mean, first of all, like I said, we don't have any data in humans on just health benefits to an otherwise healthy person. I mean, there are clinical trials ongoing for looking at the benefits of transfusion of young plasma into patients with different age-related degenerative diseases like Alzheimer's disease and Parkinson's disease. Those studies are ongoing to ask, are there benefits in the short term even of these kind of plasma transfusions? So we don't have the data yet, but those are ongoing. But there's no data in an otherwise healthy person that if you give a few transfusions of blood, that it reduces your risk of anything, any disease or any age-related disability. And so if you had done that, at the age of 20, just donated your own blood to your own self, stored it, even if you have it as you get older, I would be hesitant to say, I would say there's no evidence that getting back your own blood is going to help you live longer, delay the onset of any disease. We just don't know. And so it's not something it's not something I would encourage people to do just because it's not, we don't have scientific evidence of the benefit. But, someday I suppose it's possible. I mean, people do store cord blood with the idea that these cells might be beneficial to them some decades later. So I can't say that it won't happen, but I think we just don't have any data right now to support that.
Okay, thank you very much.
You're welcome. Just I'll throw this out. So, one of the things that I get asked a lot is, well, what do? You work in this field of aging and kind of rejuvenation and interventions. What supplements do I take? And actually, I take no supplements actually, but I do run. I run long distance. I'm a marathon runner, and like I said, I do fast 1 day a week and for 24 hours or almost 24 hours. And, that's totally anecdotal. It's not that I think 1 day of fasting is it's a very limited fast in terms of the amount of ketosis that you develop in that time. So it doesn't mimic in any way the kind of studies we've done in mice, which become very ketotic much more quickly. They're small animals and with high metabolic rates. But I think the supplements that are on the market are based on changes that we know occur in these settings of either dietary interventions or exercise or drugs that are known to promote extend life in model organisms. And to the extent that supplements are natural compounds and taking them at higher doses is safe. I have no reason to think, just like I fast, I have no reason to say that people shouldn't take them. And I think there's ample evidence that these are the pathways that are important for cellular resilience, that are likely playing a role in lifespan extension in model organisms, and that are likely to be important, even if at a diminished level, as is typically the case in humans, that potentially they could be beneficial. Any other questions or thoughts?
I have a question, but I don't want to judge only one talk. I want to give other people's.
Well, it's okay. I mean, I think people will raise their hand or chime in if they have a question. So please go ahead.
Yeah. So my question follow with for the marathons. Okay.
I missed that part. For what?
Okay. It's for the marathon, for the runners.
Marathon.
So
okay. Yeah.
Okay. Yeah. It's for the long distance of the runner. So is that any epidemiology data show the longevity for the runners? And also the second question, when they get old, what's the impact for their knee?
Yeah, I mean, both good questions, both things I care a lot about. So I think the epidemiology basically that I've read on physical activity, so is that the health benefits of exercise, physical activity, are achieved by the first amounts of exercise you do. If you do no exercise, the benefits of just having some exercise, a few hours a week, are beneficial way beyond the additional benefits that you see as you increase your exercise further and further and further. In other words, if someone were to exercise for an hour a day, several times a week, as opposed to no exercise at all, they would receive a substantial health benefit. Doubling that amount gives you less benefit. Tripling it, so that there's really diminished return, and that there's no reason to think that anyone should run marathons compared to just getting regular physical activity because of the benefits that, again, they're diminished as you increase the amount of exercise. So I would say, and this is certainly the recommendations of the American College of Sports Medicine and health fitness, government health fitness agencies, is just getting people to exercise at all is the most important thing. The difference between going from sedentary behavior to having regular exercise of some number of limited hours per week even is enormous, and that beyond that there might be slight benefits. With regard to marathoners in particular, in terms of longevity, there is evidence that people who run marathons or longer actually have a little bit of a diminished life expectancy at the high end, at the very high end in terms of long distance running. So I wouldn't encourage it, except for health reasons. I would do it just because you like doing it. And in terms of I think you asked about knees. Did you ask about knees, Dan?
Yes, yeah, for the knees, for the impact.
No, knees are a big issue. So I know we're not here to talk about marathon running, but I'll add this in that I think the evidence is that if you have any injury to joints, that then adding on to that high level endurance training actually has an impairment of function and can lead to certainly to premature osteoarthritis. Otherwise, healthy joints, though, seem to do quite well, even for prolonged distance running, for example. So the key is when one has an injury, then one has to be more careful about adding on top of that distance running when that can promote degenerative changes. So that's just for any runners out there. Did anyone have any thoughts from Eric Verdon's talk this morning? I guess I can add in some, just chime in if anybody has any questions. But one of the things that we've been studying, to the extent we can study this, is this issue of timing of diet and timing of fasting. And so what the very brief studies that I showed were just simple fasting, no food at all for 1 day, 2 days, 2.5 days in mice. But it's hard for humans to fast. Obviously, it's unpleasant, and although I know people who fast for many days, and they claim that they actually gain energy, and they feel after the initial time of being hungry, of course, and it being unpleasant, there's actually a transition to a phase in which they feel they have higher energy. And so I've not done this, so I can't even speak from anecdotal experience. But it's clearly difficult for humans to either maintain a low calorie diet, forever. So kind of just maintain caloric restriction, or even, to fast for a period of time. And so, we're very interested in exploring health benefits of different ways of modifying diet that can mimic fasting. And the supplement that, speaking of supplements, the supplement that we are exploring are these ketone bodies, and to what extent can one have a normal diet, but then take exogenous ketones? And there are, these are available as supplements that you can buy, and achieve the benefits that fasting would give without having to actually fast. And that's, in a way, that's also, one of the, I think the targets of my company and other companies is to find mimetics of fasting and mimetics of exercise, so that one could potentially take these as drugs or supplements and achieve the health benefits without the the pain of fasting or the challenges of exercising every day. And it would be, on the one hand, obviously we want, I think, just for general health reasons, encouraging both a limited diet and exercise. I think have benefits that are far broader than any single supplement will give. And so it would not be the hope that would substitute for a good diet and sustained exercise. But there may be health benefits that can be achieved through a drug or a supplement in terms of long-term prevention of age-related diseases. And that's kind of the holy grail of the field, is to develop these complex interventions into something that's much more simple and affordable, and could be basically achieved and realized in populations around the country, around the world, that would be health promoting. So I think, if there's one thing I guess I hope that comes out of a lot of the summit, is this idea of how do we develop these interventions that really can be realized by populations, not just by individuals, that really have health benefits to society. Clearly that's the long-term goal. And I think that the field of geroscience is still fairly new. And I think that we'll see a lot more of these kinds of interventions and trials looking at just health benefits and not so much treatment of disease, but prevention of disease. You can also feel free to type a question in the chat if you have or a thought in the chat if you have anything to share with the
Dr. Rando, speaking of mimetics, I mean, of course, resveratrol was all the rage for so long, et cetera, et cetera. What are your what's your take on that after, so many years have passed? Is there anything, any validity to that, et cetera?
Yeah, I mean, I think, I think it's still of interest. As you say, there was a lot of hype initially and a lot of interest in resveratrol. And then there was a lot of back, kind of contrary data. But I think the sum total of data indicates that, of course, this is in this NAD sirtuin pathway, that is one of the central pathways that when genetically modified can alter lifespan of organisms. And so I think the challenge with the resveratrol was that you couldn't possibly take enough of it to have that kind of benefit. So they were really looking for more potent analogs of resveratrol that would have the same benefit. I know the pharmaceutical approach that the industry started in on this and then stopped, but I wouldn't be surprised if again other companies come up that are pursuing these same pathways for the same basic biology, and that we see supplements coming up that are along the same pathway.
So I have such a quick question. Okay, so wherever you want to talk, just talk. Okay. So you already mentioned you don't take any thing for the dietary supplement, right?
Right.
So how about the food? So what type of the food you take and you eat? And also, what do you think about for it's called the vegan food? Called
Vegan
the
food?
vegan? Yeah.
Yeah.
So, yeah. Okay.
I mean, so I first of all, I don't follow a very strict diet, but I guess what I believe in a way, is kind of a paleo diet, right? So that the idea is that eating the diet that we were evolved to eat, before there were, cultivation of crops and so forth. And the reason why I say that is because I think likely we were evolved in terms of these issues of cellular resilience, somewhat optimized to eat the diets that were available to us over evolutionary time. And so, I think that fits kind of with a low carbohydrate diet, and there are many versions of that. But I think that was not what we evolved to eat, high carbohydrates. So I tend to go toward that kind of paleo diet. Like I said, not totally strictly, but with the assumption that a lot of the health challenges that we see as we get older in an aging society, I suspect are related to the diets that we eat that are very different than diets we were evolved to eat. So that's my own personal view, and that's the kind of diet that I tend toward. Not, like I said, not totally strictly. So that's, and then in terms of the vegan diet, again, I don't. I've never followed a vegan diet. I see the logic of why people follow a vegan diet, but it has, to me, it's less compelling from an evolutionary perspective. So I just don't have a sense of how that relates to the kind of biology that we study. So I see a question from Hillary Loft. Is there any evidence? Are there any evidence-based ways to increase the amount of stem cells in older people that we've worked with? Is it possible to answer to the prevention of chronic diseases found in the aging population? So interesting question. It's not so much, at least from our point of view, it's not so much that we want to increase the number of stem cells with age as it is we want to enhance the function of old stem cells that are already there. I mean, that was, one of the first questions we asked is, as we get older, as individuals get older and animals get older, and they repair their tissues less well, whether it's a skin wound or a bone fracture, or a muscle injury, whatever it is it because they're running out of stem cells? And the answer in almost all cases is no. The stem cells are there. They're just not working as functionally. And that's really our goal, is not so much to enhance the number of stem cells, but to develop therapies that will restore youthful properties to old stem cells. And I think, that's what I think our data on the exercise and the data from the parabiosis suggests, that these interventions allow us to, or promote, I should say, a more robust response of the old stem cells. And so, and we would very much, so to get to your question, Hillary, our goal is very much to think about this as, instead of stem cell transplantations, giving older people new stem cells or young stem cells, is, can we restore the youthful properties of the stem cells that they have already in their body? And we can do this in mice in many different ways, through these exact interventions: diet, exercise, and a variety of drugs. And so we are very interested in developing these into therapies for humans, at least for acute treatments. So you have an injury and you want your stem cells to be highly functional during that recovery response. That would be the way we would at least start in the kind of low-hanging fruit for looking at stem cell therapies related to these kind of age-related changes. So I see Emma tells me we have just a minute or so left now, I guess. A couple of minutes left. Are there any final questions before we sign off? No? Okay, well, thank you all for joining today, this morning, this afternoon, this evening. Emma, anything you wanted to say before we go?
No, thank you all for joining. And now we're sending people over to the poster hall so you can go explore everyone's posters. Thank you for attending.
Great. Thank you all. Thank you, Emma.